Hi students, welcome to the chemistry sessions. So I hope everybody is doing great. So have you revised this chapter redox reactions or not? So if not, we are going to discuss it, each and every question about it, right? Okay, let's just start with the question number 1 for redox, and 1 to 2 will be of 1 mark question. So identify the oxidizing and the reducing agent in the following reaction. You have to identify. So basically this is the reaction of how you are going to proceed by the oxidation states, if you know that, right? So in this, see here, oxide this is, so copper will be in +2 state, right? And here the copper comes out to be 0. So as you can see that +2 to 0, gain of 2 electrons. So this is what? This is reduction process which is going on, and thereby this is oxidizing agent. We have got one thing, fine. Now the next thing, now what do we have? Okay, nitrogen. So since this hydrogen will be +1 into 3, you know this because 3 hydrogens are there, that means nitrogen will be x plus 3 equals 0, x equals -3, -3 is the nitrogen, and then going out to be 0, fine. That means -3 to 0, minus of 3 electrons, and what does that mean? It's the oxidation process, and the one species which is getting oxidized, it's a good reducing agent, right? I've told you this before, fine, done. Done with the question number 1. I hope everybody has understood that. So whenever you have to find out the oxidizing and the reducing agents, you need to find out that what are the oxidation states. And next one, can we store 1 molar AgNO3 in copper vessel? And now what is the given thing? See here, the reduction potential values, right, the E0 values have been given. We know according to the electrochemical series, see here, as I told you that the one having plus oxidation state, right, the E0 potential, and the one having, again this is plus. So see here, that is how the electrochemical series is. It is actually the measure of the reducing power basically, right, reducing power. Now for the hydrogen we consider as 0, 0, that is my bar, right, and after that the values become positive, right, positive E0, and below that it becomes negative E0. That means what? What can you consider over here? See, as I'm going up, right, 0.34 will come first, 0.34 will come first, then 0.8. That means the reactivity is getting less and less as we are going upwards. Fine, that means this one is less reactive, this one is less reactive as compared to this. Negative ones are more reactive. Clear? Okay, so as I am going upwards, so the reducing power is getting reduced. Thereby, this is less reducing than Cu plus 2. That means, if I am going to store in an AgNO3, 1 molar of AgNO3 solution in a copper vessel. So this vessel is made up of copper, right, and the solution is AgNO3. The power of copper is of a good reducing agent. That means it can give up copper plus 2 ions plus 2 electrons to make this Ag into what? To make this Ag positive into Ag, right? Copper is reducing Ag because it has got more reactivity, more reducing power, fine, and that is why we cannot store. The answer is no, because both of them will going to react, and due to which the food, or can we store 1 molar? Okay, the AgNO3 solution will get spoiled. It will get converted into copper nitrate. Clear? Okay. So let's move on then. Wait for a second. Now, the next question. Question number 3. What do I have in question number 3? Here. Calculate the oxidation number of the underlined element, right? So you know how to do that. Yes, you know the drill. So we'll be just picking up a few and you are going to do it the rest. See, over here uranium it is, right? So x minus 2 into this is the oxide which I have is equal to plus 2. That means x minus x plus 4 it will be is equal to plus 2, right? Is it or not? See here, 2 2s are, okay, see it will be plus, x plus of whole thing minus. Uranium has got plus 6, okay. Now out of the 3, let us just pick up which one? Which one do you want? See, I am picking up this one, and yes, just correct it over here, we need to find out the xenon oxidation state, not of the barium. Barium again being an alkaline earth metal, its state will be plus 2, so plus 2 into 2, 4, plus x for the xenon, and this is oxide, minus 6 into 2, 12 is equal to 0. So it's 4 plus x minus 12 equals 0, and thereby x is coming out to be how much? So it's plus 8. That is what the xenon is coming out to be, plus 8. Clear? 6 2s are 12. Okay, let me just check. 2x, right. Done? Okay, so rest of them again very easy. You can very well do it on your own. Now let's move on to the next question. Question number 4. Now which of the following equations represent oxidation reduction reaction? So basically I need to find out which one is redox, right? Identify the oxidizing and the reducing agent. Fine? Okay. See here in the very first equation, again we need to go by the oxidation number method. See, potassium it will remain 1. See here, oxygen, as soon as you look at the reactants, this is a peroxide. So definitely it will be going to change in the oxide. Peroxide oxygen is minus 1 and it is going to be as minus 2, and also over here as well it's going to be minus 2. Thereby what is happening over here? Tell me. Minus 1 getting converted to minus 2, it's a reduction process, yes? But can you see any oxidation process? See, oxide it is there, hydrogen is plus 1 everywhere, over here as well, right? So I cannot see any oxidation process going on, right? So this is not a redox. Next one, chromium, this is plus 6, minus 2 is the oxygen, again minus 2 plus 1. Chromium here, 4 2s are 8, okay. So it will be plus 6, fine, is it? 4 to x minus 8 equals minus 2, yes, definitely this is plus 6. So it's plus 6, oxide minus 2, plus 1. Can you see any oxidation or reduction process happening? I cannot see any, right? This is not a redox. Next one, K, 0, oxygen elemental state, 0. Here this is superoxide. That means oxygen will be having minus half and potassium will be having plus 1 state. So what do you observe over here? 0 getting converted to plus 1. That means this is the oxidation process, loss of 1 electron. Here it is a reduction process, gain of half of the electrons, right? And that means which is the oxidizing agent over here? This is the one which is getting reduced, and which is the reducing agent? The one getting oxidized. Yes? Okay. So yes, I can call it as a redox reaction because it involves both of the processes. Now let's move on to the very last, calcium plus 2, plus 2. Carbon over here, same state. Carbon over here, same. You can very well check also. Oxygen minus 2, minus 2, minus 2. Everywhere minus 2, no, it's not a redox. Done? I hope that is clear to you. Okay, so everywhere you need to find out the oxidation processes, oxidation states basically. Okay, now question number 5, again we need to find out the oxidation numbers. All of them are very simple except one, this one. This is the paradox, right? I have told you that we need to find out the sulfur states, right, in each of them. Sodium is always going to be plus 1, right? Let us just consider the first one. So basically it's, this entire species will be -2 because this will be +2, fine. S2, O3, 2 negative, right? So it's 2x minus 6 equals -2. 2x equals 4, x equals 2. Sulfur has got +2 state here, right? In a similar manner I can find out over here. In a similar manner I can find out over here. So it is going to be +4 again, it is going to be +6 here, right? You can very well find out. But what is the paradox over here? I told you it has got a different state. See here, it is having a structure like this. Thereby, 2 of the sulfurs will be having 0 oxidation states and this sulfur will be having +5 and +5. Done? So that is an exception, you must remember this. Done, question number 5. Okay. Let's now take up the next question. Question number 6. Okay. Arrange the following molecules, the decreasing order of oxidation states. So I need to go by positive to negative. For nitrogen we have to find out. Fine? Okay. See here, nitrogen dioxide. It's easy. So it is +4 it is coming out to be, because all together it will be -2, oxide it is. See here, we have already find out this. -3 it is going to be, right? Okay. This one, see here, this is hydrazoic acid, right? And if you try to find out the nitrogen oxidation state, it comes out to be, see here, if I assume that this hydrogen is +1 minus 3x equals 0, sorry, +1 plus 3x, right? -1/3 is the state, right? It's the fractional state which is coming out to be. Thereby, the structure of this molecule is somewhat like this. And that is why each and every nitrogen is having different state. 2 of the nitrogens is having 0 state over here and 1 is having -1, right? That is why I am coming out to be, the oxidation state is coming out to be -1/3. Clear? So that is an exception, mark this out. This one again you can very well find out. So it will come out to be x minus 4 equals -1, x equals 2 plus 3. Done? Okay. Now this, what is this? Hydrazine. In hydrazine, 2x minus plus 4 equals 0, x is coming out to be -2, right? Clear? Done? So I hope everybody is done with it, and yes, now you can very well arrange it into the decreasing order. That is, I am not going to do it for you, right? Okay. Now let's move on to the question number 7. What do I have in the question number 7? Okay. Which of the following is oxidation and which is reduction? Now it's a very easy question. See, what do I have to do? See here, +1 state, right? You cannot just simply look at the electrons. Try to analyze the entire equation. +1 getting onto 0 state, right? What is this? Reduction process. Simple and easy. Aluminium losing electrons, oxidation process, easy. Fe3 plus, now Fe3 plus is actually getting to Fe2 plus, right? It is actually taking up electrons. So this electron has written over here just to confuse you, fine? Because after all, if it's going to gain the electron, that means I need to -1 electron so that I equal out the 2 sides, yes? So thereby this is what? It's a reduction process. Clear? Oxygen, now O2 negative, earlier it was, O2 negative is there, carbon 0, carbon +4, got it? What is it now? It's the oxidation process which is happening. Clear? Okay, next one. Br negative to Br 0. What is it? Again oxidation, loss of the electrons. Now here +1, +1, -2, 0, -2 to 0. That means again the loss of electrons. Now they have written the electrons over here, this side, just to confuse you again. And this is what? Again the oxidation process. Clear? So that was pretty easy. Okay. So that was question number 7. Let's move on to the question number 8. Now, it is the 4-mark question, very interesting one. See, on the basis of the standard electron potential values, right, suggest which of the following reactions would take place. Okay. Now, what we have to find out is which reaction is taking place. See here, it's a very important point, write it down, that whenever we have to check whether the reaction is taking place or not, we need to have the E naught of the cathode, right, cathode process, minus E naught of the anode process, right. And if the final E naught of the entire cell, it comes out to be positive, then the reaction occurs, reaction is feasible, right. If E naught of the cell is minus, that means reaction does not occur. Clear? And that is what you have to do, right? Now, you must be wondering that what cathode and what anode processes are. Cathode process will be the reduction process. You need to figure it out, what is the reduction process going on in the reaction, and anode is the oxidation process. Simply you just need to put the values and you will get the answer. So here are the equations given, and if you need to find out the values, I've got the values for you as well. Fine, okay. Let's now try to check it out with the very first one. Copper plus Zn2 plus. Now first of all, what is the oxidation, what is the reduction process? See here, this is the oxidation and this is reduction, right? That means copper plus 2 and copper. This one we will be taking as the oxidation process and Zn2 plus to Zn we will be taking as the reduction process, right? And why I have written like this, it's kind of a representation of the cell of the half reactions, that the reduction process is written to the left and then the oxidation process. Clear? Okay, oxidized state. Sorry, this is the oxidized state which we write and this is the reduced state. Okay? Now I just need to check the values for both of them, copper and zinc. Let's check. Okay, see here, copper, it's 0.34, right? I'm going to write it here, 0.34, and for zinc, it's minus 0.76. I hope that is visible to you. Okay, minus 0.76, right? Okay. Now what I need to do is just put the values over here. It will be minus 0.76 because that is the reduction process and minus of 0.34, right? The overall value will come out to be minus definitely, so it is not feasible. Reaction number 1 is not possible. Okay, got it? Okay, let's move on then. Now the next one, I need to figure it out, Mg and Mg2 plus, right? So this is what? Oxidation process going on, right? And this reduction going on. So Fe2 plus to Fe, see here, Fe plus 2 to Fe value I need, which is the reduction process, that is the cathode, minus Mg plus 2 to Mg, right? This value I need, which is the oxidation process, see here. Okay, Fe minus 0.44 minus of Mg, it's minus 2.36, minus minus plus 0.44 plus 2.36. Very well, the value is coming out to be positive, and yes, this is feasible. So the reaction number 2 will be possible. This is possible, this was not possible. See here, now for the bromine. Now, Br2 to Br negative, right? Okay, so Br2 to Br negative, that means this is the reduction which is happening. Okay, minus of Cl negative to Cl0, it's the oxidation, Cl negative to Cl0, right? It's the reduction. I just need the values. Okay, so the values for bromine, it is 1.09 minus of the chlorine, where is it? Okay, 1.36. Now, can you judge that how much will be the value? It will be in negative, right? And that is why the process number 3 is not feasible. Now, if I try to calculate for the cadmium and this, right? See, this is reduction process. So, cadmium plus 2 to cadmium minus of Fe, Fe plus 2 to Fe. Let's put the values then. Okay. So, cadmium, where is it? Yeah, minus 0.4 minus of Fe, it's minus of 0.44, right? So, it is coming out to be what? How much? It's coming out to be the positive, right? And thereby, this process is feasible. Clear? Okay, that is how you are going to find out. Okay, now, let's move on further to the next reaction. Next question. Right. Question number 9. Now, the balancing part. So, basically, we are not going to balance it over here. I'll be just writing down the equations and will be giving you the idea that how the process takes place, right? You have to do it on your own. So, permanganate, MnO4, right, reacts with sulfur dioxide gas, giving Mn plus 2, right, plus hydrogen sulfate, HSO4 ion. And this particular reaction will be taking place in the acidic medium, right? Okay. So, what you have to do, they ask for the ion electron method, right? In ion electron, you remember, so first of all the reduction half. What is the reduction half? This is the reduction half. You need to separate reduction half and you need to separate oxidation half. Second step, what will be? Second step will be, you need to balance the atoms. Balance atoms, right? So, that is the second step. Okay, you need to first write the both of the things separately, oxidation and reduction half, balance the atoms. After that, balance the oxygens, then balance the hydrogens via H positives. Fine. And finally, fourth point, balance the electrons and you will be done, right? So, we are not going to solve it anyway because we have done ample amount of examples in the class. If you have got any confusion, again you can reach out to me for that. It's a very simple reaction actually, right? Okay, now let's move on to the next part. A reaction of liquid hydrazine. Okay, let's just write the reaction then. Liquid hydrazine N2H4 plus chlorate ion ClO3 negative will give nitric oxide NO plus Cl negative. So, it is also a very simple reaction and we have found out the state for this nitrogen as well and we can find out the state for this nitrogen as well, right? Clear? Okay. So, now they are asking for the oxidation number method. It's very simple. Oxidation number, you need to first find out that where the oxidation is taking place. So, first of all is electron balance along with atom balance, right? And then what you have to do? Balance the charges, balance charge via H positive or OH negative, and then lastly balance hydrogens via putting the water molecules and you will be done, right? So, you have to practice it on your own. Okay. Now, let's move on further to the question number 10th, the last one. Okay. Consider the following table. So, it's a very interesting question. See here, Okay, so these are the reactions which are given, E naught values are given. You need to study the E naught values. As I told you, the ones which are having positive, they are good oxidizing agents, right? And the one with negative, these are good reducing agents. Reducing agent means itself getting oxidized. And oxidizing agent means itself getting reduced, right? Okay, done. Now we have analyzed the equations. Which substance is strongest oxidizing agent? Tell me. Definitely this, yes. So we'll name it as Al+3. Now, which is the strongest reducing agent? We know reducing agent having the most negative value. So it will be D positive. Done. Which substance can be oxidized by B+2? Now, which is a better oxidizing agent? B+2 they are asking. This is a very good oxidizing agent. It can oxidize these two, right? Are you getting it? Okay, so C+2 and D+ can be oxidized. Which substance can be reduced by C? Now C is here, right? It is a good reducing agent. So it is itself getting oxidized, and to which it is reducing? These two quantities it can reduce, right? Because they are getting reduced. Clear? Okay. So Al+3 and B+2. Done? Okay. Write a balanced chemical equation. Now this is important for an overall cell reaction that gives highest cell voltage. Highest cell voltage. How can I find out the highest cell voltage? For that, I need is reduction process minus oxidation. We know this. And reduction minus oxidation must be somehow that I get the highest value. Fine. And in that case, what you can do? Tell me. So it will be, see, if I add up this minus and minus of 1.42, right? These two values, I'll be getting the highest of all, right? That means, see here, this is the reduction process which is happening, right? So that means we can have this reduction process over here. We can take up this value very well. So my equation will be aluminium +3, right? Sorry, A+3 along with C. Involvement of D is there, right? So D will be getting what? Getting reduced. So I'll be getting is Al+ plus D positive. Fine. Now I need the balancing, because here see charges are not balanced. This is +3 equation, right? They are wanting a properly balanced chemical equation, right? So it is +3 charge, over here it's +2. How can I make one more charge extra to this particular side? By making this D as 2, right? Done. So it won't affect because here D is itself 0. I will not have taken this as 2 because then I'll have to make this A also 2 and it would have increased the charge. So that is why I've put 2 in front of this particular D. Clear? And that is what the entire reaction is. And with this reaction, see here, this is the reduction process, that means this value. This is the oxidation process, that means this value, and total E0 cell will be the highest, right? You can just try out with any of them. These two will be the highest always. And I hope everybody has got it. If not, if some of you are still having any confusion, you can always reach out to me, and then first of all just try it out these questions by yourself so that you are able to do it on your own. Fine? Have a nice day.